This problem called strange mathematics. This problem, I'm going to start by reading it, and then we'll talk about how to understand it a bit, and then we'll lay out cases that we need to handle in solving this problem, and finally we will write our code. Like usual, I'm going to actually delete the tests that we have here, leaving only the describe block. We'll get into those a bit later. So here we go. In a certain kingdom, strange mathematics is taught at school. Its main difference from ordinary mathematics is that the numbers in it are not ordered in ascending order, but lexigraphically, as in a dictionary, first by the first digit, then if the first digit is equal, by the second, and so on. In addition, we do not consider an infinite set of natural numbers, but only the first n numbers. So for example, if n equals 11, then the numbers in strange mathematics are ordered as follows: 1, 10, 11, then 2 through 9. Help your students to learn this science. Write a function that receives two integer numbers, n. Two integer numbers. First, n, the total amount of numbers in strange mathematics, and k, a number from the sequence, and returns the location of a given number, k, in the order defined in strange mathematics. For example, if n equals 11 and k equals 2, the function should return 4 as the answer. N is greater than or equal to 1 and less than or equal to 100,000. And k is greater than or equal to 1 and less than or equal to n. The output we're looking for is the position of the number k in sequence of the first n natural numbers in lexicographic order. Numbering starts with 1. And then we have a couple examples here, where the first example is n is 11 and k is 2. So to sort of puzzle out this example, I remember that the example given here is also n equals 11, and the order of the numbers is right here. We're looking for the position of 2, so we start at 1. We see position 1, position 2, position 3, position 4. The number 2 is in the 4th position, and sure enough, the answer here is 4. So the next example is 15, and what is the position of 5? It is 11. So I'm going to go ahead and copy this for now. Come over to a nice clean replit. I'm going to paste that there as a comment. So first let me think about 1 through 15 is going to look like 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. However, the numbers aren't ordered the way they're normally ordered, but anything with a 1 is going to be moved right behind 1, almost as if they were alphabetically ordered, where 1 is first, and then comes any number starting with 2, and then any number starting with 3, etc. And the number we're looking for is 5, so I'm just going to count this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In the 11th place, we find the number 5, and then sure enough, we see the number is 11. Let's look at the last example. 15 and 15. So again, I'm just going to paste that in. Well, we've already got the same number set, so we don't need to redo our numbers. We do need to find the number 15. So I'll start here. 1, 2, 3, 4, 5, 6, 7. In the 7th position, we find the number 15, and indeed we see the number 7. So we're going to have to find our numbers from 1 to n, then put them in this strange order, and then find the number that the problem is looking for. So let's break this down into some cases that we need to look for in this problem. So the first case, we know that n is always going to be 1. 1 or greater, I'm sorry. So we don't need to worry about n is undefined or n is 0 or anything like that. So I think we can define pretty simply. The first case is n is less than 10. Because if n is less than 10, our biggest problem set, or our biggest number set, is going to look like this, 1 through 9. And if these are all the numbers we have, or any portion of them, for example, if we had 1, 2, 3, 4, we don't need to do anything with these numbers other than skip to our next step, which is find whatever k is. Now, the problem tells us that k is greater than or equal to 1 and less than or equal to n. So n is our last number, and 1 is our first number. So we shouldn't have to worry about k being out of bounds. So I think that case is, that's pretty much it. N is less than 10. Let's move on to another case. N is less than 20. Now, we could just say N is greater than 10, because that's the point at which we're going to have to start sorting things. But for the sake of keeping it manageable for our minds, I'm going to say N is less than 20. So let's imagine that N equals 16 and K equals 12. So first we would need this number set. I'm going to start by stealing this set here. So this is N equals 15. All we need to do is figure out where 16 would fit in here. Slots in right behind 15. And then if we want to find the position of 12, we just start here. 1, 2, 3, 4. In that case, the answer equals 4. Great. And then let's look at one more example of N is less than 20. So we might say N is 19 and K is 4. And our answer is what? We don't know. Again, I'm going to copy this set of numbers, paste them here. I need to add in 17, 18, and 19. Oops. And then we're looking for 4. So I say that 4, I can just eye it and see that 4 is closer to the back than the front. So I'm actually going to start by counting backwards. 9, we know that 9 is in the 19th spot because we have 19 numbers total. So we'll count 19, 18, 17, 16, 15, 14. 4 is in the 14th spot. Great. Let's move on to another case. Now, obviously, in this case here, N is less than 20 is everything from N is 11 all the way up to N is 19. A lot of times, we're only going to write 2 tests for each case if we feel like that adequately covers it, and I think this more than adequately covers it. So here I'm going to do N is less than, now we could do N is less than 30 maybe, less than 40, but the next case I want to jump to that I think is a big enough jump to offer at least a little bit more coverage is N is less than, we're going to say greater than, N is greater than 99. And what I'm trying to look for here is making sure that when we get to 100, 100 goes all the way back behind 10 when we sort this out. It should be the same logic as N is greater than 10. So all these cases should follow the same logic, but let's be confident and sure and make sure. So N is greater than 99. What can we do here? We can say N equals 101. K equals, in fact, we'll start with something easy. K equals 99. Now, why is that easy? Because we have 1, 10, 100, 101, 11, and so on, all the way up to 98, 99. And 99 is going to be lexicographically the highest number in this sequence, and so it's going to be in the last position. That being the case, we know that our answer that we expect is 101 because we have 101 total numbers and 99 is in the last place. Let's look at one other thing. How about N is equal to 101? K is equal to 2. And what would that look like for the answer? Well, we'd have 1, 10, 100, 101, 11, 12, 13, 14, 15, 16, 17, 18, 19, 2. And after 2, we'd have many more values, but we're not going to finish those out. We would say 2, 20, 21, and etc. So let's count this out. We were looking for the position of 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the answer we expect here is 2 is 14. Let's start with that. We've got this case here, N is less than 10. Then we have N is less than 20. Then we could do an intermediary step here. For example, N is greater than 20 but less than 100. but I think we'll just jump right to n is greater than 99. And then of course we could go on from there to n is greater than 999 and 3 digits, 4 digits, all the way up to 5 digits, because we know that it's going to be less than 100,000, or maybe less than or equal to 100,000. But this is probably sufficient coverage for this problem. So when I get started over here, first thing I do is I copy the message that I wrote for my first case. Oftentimes someone has just stubbed in some kind of basic tests here. So when I describe, I usually just put the name of the function that we're describing. And then the way we write our test is we start with it. Inside the it block, I put my case. Sometimes I add a helper word here. It handles n is less than 10. We make a callback function. And here we want to do assert equal strange math. We're going to pass in our arguments, and we're going to then get our expected result. To get my arguments, I typically just go back and refer to what I did here. Here's the example I set up. I'm sorry, I didn't set up examples for n is less than 10, only because it's fairly trivial. So let's make some up now. N is equal to 6, k is equal to 3. So we know that our number set would look like this, and 3 is in the third position. So the answer equals 3. Let's look at one more. N is equal to 9, k is equal to 7, and we know that, again, because we're not actually changing any of the order, 7 is in the 7th position. So I'm going to start with 6 and 3. So n is 6, k is 3, and we said it's in the third position. Now when we're following test-driven development, the first thing I'm going to do is, I've written a new test. I'm going to go ahead and run it. Looks like, did I make a mistake here? Describe, strange math, callback. That goes to here, yes. I made a mistake here. Looks like when I initially deleted it, I didn't run it correctly. Okay, we get a failing test. Expected undefined equal 3. So when we're doing test-driven development, we simply want to return the least amount of code to make our test pass. We'll do return 3, and what do you know, it's passing. Now, of course, we need to test more cases, the second case that we came up with, or the second example of this case, rather. So we have strange math, and the second one we said was 9 with 7, and the expected value is 7. And I'm going to go ahead and run that. And if you're wondering where I'm getting that 9 and 7, that is the numbers that I came up with that followed this rule. N is less than 10. So n is 9, yep, less than 10. K is greater than or equal to 1, and less than or equal to n, 7. Yep, perfect. And we just can eyeball it and see that 7 is in the 7th position. So all good there. Let's go back here. Expected 3 to equal 7. So we're returning 3 very explicitly, and this test is now failing. So that's not a problem. We just need to refactor our code. So I see that k is 3, and we return 3, and k is 7, and we return 7. So let's just go ahead and return k. Go ahead and test that. And it looks like we're good. So now we're ready to move on to our next case. So we got to get some bold or something going on here. This represents our first case here, n is less than 10. Now we're working now here, n is less than 20. So just like last time, I'm going to copy this. I'm going to start a new it block. It handles n is less than 20. Callback function, assert equal strange math. And now I'm back to looking at the numbers that I picked before we even started, 16 and 12, with the answer being 4. So I'll do 16 and 12, with the expected answer being 4. Great, I'm going to run that. And no surprise it fails, because right now we're just returning k, and here k is 12, and we expect 4. So we'll have to get into really figuring out now how to order our numbers in this sort of strange way. Now, we could always think to ourselves, if you felt stuck on this problem, you could say, what should I Google? And we could ask ourselves that question, and we might say, how to order numbers lexigraphically in JavaScript. That would be a great thing to Google. Sometimes when we're working on problems like this, what is not helpful to you at all as a developer is to just like look for Codewars strange mathematics solution and just Google a solution. You're going to really, stunt your growth as a developer. But what's totally normal and good thing to do is come across a novel problem or novel to you, how to order numbers lexigraphically, and then just go ahead and Google it, and you'll usually find even more than one way to do it, but at least one way to do it. Now, I happen to know that when we use sort, let's say we've got 1, 3, 2, and 5. And we call sort on that. It's ordered it nicely for us in smallest to greatest order. However, we have another property here built into sort, which can often be frustrating, but sometimes good, where we do 1 and 3, 11, 12, 6. And let's go ahead and sort that. And what do you know? The way sort works is it tends to treat things like they were strings and then sort them lexigraphically, as long as we don't pass anything into the sort method. So here we see this resembles what we're looking for, where 1 is followed by 11, 12, 3, and 6. So let's use one of our number sets here. I'm going to copy this, but take these out of order so it's more like in its regular order here. I've got a period instead of a comma. Let's go ahead and paste this in here. Try sorting that. I'm not sure if I got a mistake there. Okay, great. Comes back 1, 10, 11, 12, 13, 14, 15, 2, 3, 4, 5, 6, 7, 8, 9. So that looks pretty reliable. We can at least start to work with something like that. So then if we think about how we're going to solve this problem, we can say we need to create an array. We need to fill the array with 1 through n. We need to order the array lexigraphically. There we go. We need to iterate through the array, and then each time checking if the number is equal to k, and if so, return the position. And because arrays are indexed at 0, its position would actually be 1 less than it is, so we're going to say position plus 1. Now that we've laid out those steps, that's what's going to take to solve this example here. So let's go ahead and walk through these. Actually, we have return here. That's fine. So let's create the array. Let array equals an empty array. Let's fill the array with 1 through n. We're just going to simply do this with a for loop. Let I equals 1, and we're starting at 1 because it told us that we're really only looking at 1 through n. I is less than or equal to n, and we're going to increment by 1. Inside of here, we want to push I. So the first time the loop runs, I is 1, the second time I is 2, I is 3, etc., which will create an array that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. Now, we did a little sketching, as it were, over here to see how to sort it, or you could have Googled how to sort numbers lexigraphically. Actually, let's just Google that out of curiosity to see what kind of results you would get. Looks like we have some kind of answer here. How do I sort numbers lexigraphically? Let's go ahead and click on this one. Now, it looks like this is not JavaScript. In fact, it looks like very much not JavaScript. Let's try here. I'm always just kind of glancing through to see what might make sense. These all look pretty complicated. How about this? JavaScript's array sort function sorts by lexicographic order automatically. Okay, so we could always get more into this if we needed to, but I feel pretty confident that this is a good solution for us. So let's go ahead and do that. We want array.sort. And sort changes an array permanently, so we don't need to save array to this. We can just, for example, we don't need to do array equals array.sort. We can just do array.sort. All right, then we're going to iterate through the array again. So iterate doesn't always mean, but usually means a loop. So let I equals 0. Now we're starting at the first index of this array. I is less than array.length, I++. And then here, this is going to go inside of the array. Each time, again, these, if we can kind of walk through the instructions, then they almost act like our boss as we're putting together the function, because now it says each time checking if the number is equal to k. So if array I is equal to k, return I. And then we say the position is I, but we want to return I plus 1. Now, who knows anymore if we're going to get to return k? I don't think we are, and we'll address that in just a second as we refactor. But I think at this point we should have a solution to what's on line 10. Let's go ahead and run the test. Yep, looks like it worked. So we created our array, we filled our array, we sorted the numbers, and then we walked through it looking for the index of k, and then adding 1 to the index, since the index is always going to be 1 less than the position of the number. All right, let's go ahead and look to the next example here. So we're still on n is less than 20, and now we have n is 19, k is 4, where the answer is 14. So I will copy this, and we'll do another one here. So we have 19, looking for 4, I think we said, and the position is 14. Is that right? 4, 14. Yep. And let's go ahead and test that. Great. Looks good. So we note that we're always continuing to pass the original tests we did and still passing the additional tests. Let's go ahead and move to the next case. N is greater than 99. So I will do it handles n is greater than 99, setting up a callback, and writing out assert dot equal strange math. And when I get to here, I always refer back to the arguments that I had previously set up. So we have 101 and 99 with the answer being 101. So we'll try 101, 99 with the answer being 101. And let's go ahead and test that. Looks like it's good. We've got one more here, 101 and 2, with the answer being 14. Yep. So I will do 101, looking for 2. Oh, I'm sorry, I didn't mean to overwrite that. Let me write another line here. We don't want to overwrite our tests because we want what's called good test coverage. 101, 2. And we said that we expect it in position 14. Let me go ahead and test that. Looks good. Okay, at this point we've come to the end of our test cases that we laid out. We just laid out those 3. So I'm going to do some refactoring. First of all, we have kind of this dangling return k here, which, as given the problem the way it's laid out, we're never actually going to get to k. At the same time, although JavaScript allows us to return from inside of our for loop, or an if statement, I don't want that to be the pattern that we follow. So I'm going to go ahead and set up an array for let position of k. And we'll just set that to 0. And then instead of returning here, I'm going to set this to position of k equals. And then finally, instead of returning k, I'm going to return position of k. Now, in some languages, you would have to do this because it won't let you put a return statement nested inside of an if statement. In JavaScript, you don't have to do this, but it is a cleaner way to even just kind of glance at this. Position of k is what we're looking for. Position of k is what we're returning. I tend to think of that kind of like a bookend for the problem. Here's the cover of the book. Here's the end of the book. What are we doing in the meantime, in the middle of the book? I just think it's a clearer pattern, and I recommend that you use it. The other thing I like to do is I like to treat these comments as scaffolding, but I like to delete them before I'm getting closer to submitting a final solution. I just like to see my code more clean and clear. I like to clean up any empty spaces. 1 space is enough for separating out little ideas. We don't need 2 spaces. Looks good. Now, when I'm at a step like this, I'm just going right back to my tests. I've changed enough things to not know if I might have made a mistake. Looks like they're all still working. And we're going to go ahead and click on attempt. Run attempt. We've passed all the automated tests, which looks good. I'm happy with my code. I'm going to go ahead and submit it. Great. We move on to looking at a couple other solutions. Let's look at this first solution here. They set up their array. Now they did return from the last line, which is great, kind of like we did, but they didn't choose to do it from a separate variable, which is fine. They set up their array with 0. They have a loop like we did to push all the values into it. Then on the last line, they're sorting it first, and then they're using index of k. So in ours, we did 2 full loops. Theirs is actually doing the same thing, although one of the loops is abstracted away, and it's happening inside of this call to index of. All good and fine, and then we'll go to the next one. Here they use array.from to create the array, just like we did with our loop. And then looks like they iterate through, changing each number to a string, sorting them, and then using index of, looking for that string value, taking this variable, turning it into a string value, and looking for that. Both pretty similar to ours, and of course you could go and look at some other ones, but we will stop there.